Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're going to be taking a look at the midpoint formula and also the tangent lines of circles in the xy plane. We're going to combine a bit of everything of what we've done so far. It's going to be a lovely ride. Let's have some fun. Okay, so what do I mean by the whole idea of midpoint? Well, this is exactly what I mean. Let's say you've got any single 2 points in the xy plane, x1, y1, and x2, y2, and you want to find the coordinates of the point, which is exactly halfway along the straight line that connects them. Okay, that seems like a useful idea, right? But how are we going to find that out? I mean, we're going to have to find some expression involving x1, y1, and x2, y2, which to get the point exactly halfway along the straight line that connects them. Well, if you're clever, here's something you might notice. This middle point here, because it's literally in the middle of x1, y1, and x2, y2, it also is exactly halfway, halfway like on the line which connects the 2 points vertically. And what I mean by that is that the vertical distance from here to here is exactly the same as here to here. It's because it's in the middle of the 2 points. It exactly cuts halfway along the vertical line that connects them. And similarly, if you draw a little dotted line up here, you can see that it is also exactly halfway along the horizontal line that connects the 2 points. In other words, this is another way you can think of this. It's the average of the point's x coordinates and the average of the point's y coordinates. Now, that probably makes no sense to you. Let me explain it like this. Imagine you've got a point here and a point here, and this point has x coordinate 4, and this point has x coordinate 6. How do you find the x coordinate? Sorry, that is the y coordinate. My brain, sorry. I'm so sorry. Anyway, how do you find the y coordinate that is exactly halfway in between 4 and 6? Well, you probably bark back at me 5. But how would you do that, not knowing these two numbers specifically with just general variables? Well, you take the average, wouldn't you? You take 6 plus 4 and divide it by 2, which get you 10 over 2, which is 5. In other words, you're finding the average x coordinate and the average y coordinate of the points you're dealing with, which in other words results in the formula. For the x coordinate of the midpoint, you're finding the average x coordinates of the 2 points, so the average is x1 plus x2 divided by 2. And then similarly, the average y coordinate is y1 plus y2 all over 2. So there we go. This little expression here gives us a formula for the midpoint of 2 points in the xy plane, i.e. the point that is exactly halfway between them. And we found that out by realizing that the midpoint is exactly halfway the vertical distance between them, and also halfway the horizontal distance between them because of its nature of being the point in the middle. And we realized that we could express the x coordinate and the y coordinate of this point by taking the average x coordinates of here and here and the average y coordinates of here and here, because again, it is exactly halfway between them. I think that's pretty cool if you ask me. Anyway, let's go on to the next bit. Okay, so the next thing we're going to deal with is how do you figure out the equation of a tangent line off of a circle? And remembering that the tangent line specifically is a line such that it just comes in, just kisses the circle, and then leaves again. So how do we find the equation of any tangent line knowing the equation of the circle? Well, again, if you're clever, here's something you might notice, is that, or just something you might remember from GCSE, is that if you draw out the radius of the circle, it's going to be perpendicular to the tangent line. And that means you can use the fact that, well, you probably know the center of the circle, and in the question you'll be told the point of tangency. If you don't, then that's really bad. But if you'll know these 2 points, and from there you can get the gradient of this line that connects them, and then you can use the fact we derived earlier in the series that the gradients of two lines that are perpendicular multiply to equal -1, and you can say, well, this times this equals -1, and then you can solve for the gradient of the tangent line, and then you also know that it passes through this point, so then you can set up another equation to find the y-intercept, and that is how you tackle equation of tangency problems. We're going to have a look at some of those now. Okay, so this problem goes like this. The points -1, 2 and 5, 10 form the diameter of a circle C, and our first task is to find the equation of circle C in the xy plane. Now, as you'll recall, to find the equation of a circle, we're going to need its center point and its radius. So, how are we going to get its center point and how are we going to get its radius? Well, here's a nice trick we can use. We know that these 2 points form a diameter of the circle, so their midpoint should be the center of the circle. I'll show you what I mean. if you don't already get it. So if we've got point here and they form a diameter, it should make some geometrical kind of intuitive sense that taking the midpoint should result in the exact center point of the circle, which is very interesting if you ask me. So to get the center of the circle, we're just going to take the midpoint of these 2 points, and then we're going to figure out the radius after that somehow. Anyway, if I just rub this bit out, let's figure out the midpoint of those 2 points. Recalling the formula we just derived, the midpoint, which I'll call M, will be the sum of the x coordinates divided by 2, which turns out to be 3, and then the sum of the y coordinates divided by 2, which turns out to be 6. So the center of this circle is at 3, 6. Okay, that's fantastic. But how are we going to get the radius of the circle? Well, if you've watched my last video, you'll know exactly how. We've got 2 points that form a diameter. So if we calculate the distance between those points, we can get the diameter of the circle, like the length of the diameter. And if we half that, we'll get the radius, which is really, really cool. So let's use the distance formula that we derived last video about on these 2 points to get the diameter. Okay, so we're going to open the square root, and then we're going to take the difference between the x coordinates, remembering that it doesn't matter which order we do the subtraction in. We could do 5 minus minus 1 or minus 1 minus 5, and we get the same result at the end. I'm going to do minus 1 minus 5, because why not, which gets us minus 6 squared. And then we're going to add that to, I'm going to do 10 minus 2 to get the difference between the y coordinates, which gives us 8. And that is equal to the distance between them squared. Now, negative 6 squared plus 8 squared, you can run it through your calculator if you want, that results in exactly 100, which is, in fact, taking the square root of that, results in 10. So the diameter of the circle is 10, in other words, the radius is 5, which means we've got all the information we need. Oh yeah, the radius is 5 because, you half it to get the diameter, which means we've got all we need to find the equation of the circle, which is, let's be careful about this, x. We take the negative of this number, we take the negative coordinate of this x coordinate, the center of the circle, square that, do the same thing with the y coordinate, take the negative of the center point here, and we set that equal to the radius squared, which is 25. Boom, there is part A completed. Whew, not too much work, not too bad, right? Whew, right, now let's do part B. This is the fun part. Okay, so part B goes like this. Find the equation of the tangent line to C at 5, 10. Okay, let's remind ourselves what it means for the tangent line at 5, 10 to the circle. So let's draw our circle. Boom, there's its center at 3, 6, lovely jubbly. And 5, 10 will just be about up here. Okay, and we need to find the equation of this tangent line here that just comes in and just kisses the circle just once. Recall that if we draw the radius out here, then by definition, the radius and the tangent line will be perpendicular to each other. So, and since we also know this point is 5, 10, we can calculate the gradient of this line and then use the relationship between perpendicular gradients to get the gradient of this line, and then we can also plug in 5, 10 and get the equation of it, and we'll be very, very happy with ourselves. Okay, so let's do it. If I just rub out this quickly. Right, so we need to find the gradients between the points 5, 10 and 3, 6. If you remember the diagram, we're going to expect a positive gradient and we're going to want it to be kind of big. So let's do that. We're going to take the difference. Actually, let's just draw out what we've done here. We had 3, 6 and 5, 10. Okay, fantastic. Now, we calculate the gradient as such. Let's look at the difference between the x coordinates to get this little bit here, which is 2, and the difference between the y coordinates, which is 4, and then we calculate the gradient. Oh, by the way, yeah, if you don't remember any of this, got a video about it, so you'll be set. We take 4 divided by 2 to get the ratio between y and x, which is always a constant, the gradient, which is 2. Fantastic, 2. Okay, right, and now we're going to use the relationship that this will be the tangent line, by the way. Nice, lovely jubbly. And we're going to use the relationship that perpendicular gradients multiplied to be -1. So we know that 2 multiplied by the gradient of our tangent line should be equal to -1. Or in other words, the gradient of the tangent line should be equal to -1/2. You can do that maths in your head if you like. Anyway, so now we know the gradient of our tangent line, and we also know a point that it crosses, i.e. this point, because it's tangent to the circle at that point, so it just comes in and kisses the circle at that point. So all we need to do is set up an equation involving And we just plug these coordinates into the equation of the line, and then we'll be set. Whew, I'm getting out of breath doing this. Anyway, let's go. So we know that the line must have some equation y equals minus a half x and then plus some y-intercept c, and we want to solve for c so we can finish getting the equation. Now, we know that because 510 crosses the line, its coordinates must satisfy this equation, so that means that 10 has to equal negative a half times 5 plus c. Okay, lovely jubbly. Negative a half times 5 is, well, just negative 5 over 2. Add that on both sides, you get c equals 5 over 2 plus 10. Or in other words, c equals 5 over 2 plus 20 over 2, which equals 25 over 2. Fan-dabby-dozy. Let's do just a bit more rubbing out and we can finish all of this. And we'll get that the final answer is y equals negative a half x plus 25 over 2. Actually, I don't like how that looks, to be honest, so let's just clean it up a bit. We can multiply both sides by 2. Why not? It's still the same equation. If we multiply both sides by 2, we'll get 2y equals negative x plus 25. And then we can just add this x over, because who likes negatives? And then we'll get that 2y plus x equals 25 is the equation involving x and y, which represents the line of tangent C to the circle C at point 5, 10. Whew. That was a lot of work, justifiably so as well. In the exam, you usually get a lot of marks for questions like this, so it's good to know how to do them. And it's also bucket loads of fun. Anyway, that'll be it for this video. It was just a quick little video explaining how to do these types of questions, because then we're going to knock it out of the park with the next few videos about intersecting graphs, and that's when all of this will become just kind of easy compared to intersecting graphs, and it will all be very fun as well. And we're going to apply every single thing we've learned so far to that, and then we'll be done with the XY plane and all of that stuff. Anyway, thank you very much for watching this video. I'm really, really hungry now, so I'm going to go eat. Thank you very much, and I'll see you in the next one. Bye!